So in this video, what I want to do is run through another sample problem for a dynamics Newton's second law F equals ma problem. So when moving your 157 Newton desk, you slide it across the floor with a force of 63 newtons at 15 degrees. So the first thing we want to do is draw a force diagram. Remember, we're going to condense all of that down into a single dot that represents our desk. And when I look at the givens, I have a 157 Newton desk. That tells me the weight or the force of gravity. So I'm going to draw an arrow going down that says that's the force of gravity, 157 newtons. Now remember, we always have to know both the weight and the mass. And to find the mass, you take the weight, divide by 9.8. It comes from a special version of Newton's second law, F equals ma. If this is the force of gravity, this has to be the acceleration of gravity. So F equals m times a. If I divide both sides by 9.8, then I'm going to end up with the mass of 16.02 kilograms. Then I look at the next thing and I say, hey, there's a force that the floor is, I slide it across the force and I am putting a force of 63 newtons at 15 degrees. So in that case, then I'm going to have a force coming up this way. This is going to be 63 newtons. This is at 15 degrees. The first thing I would say is because that's at an angle, I'm going to have to break that into components. So I'm going to have an x component here of the force. That'll be 63 times the cosine of 15. Y sine because x is cosine. And that is going to be 60.85 newtons. Then I'm also going to have a y component of the force that's going upward. So that force in the y direction is going to be 63 times the sine of 15, and that's going to come out to be 16.3 newtons. Now remember, once I break that into components, then I really have gotten rid of that guy, and I'm left with just these two, the x and the y values that are going in those directions. So the next thing I look at is say, hey, is that all of the forces acting on the desk? And I probably would look at that and say, I'm not really sure because my desk isn't going to be floating or sinking. So looking in the up and down direction, if the down direction force is 157 and the up direction force is 16.3, there has to be another force pushing up on the object that balances that out. And remember, that's what we would call the normal force. It's the force that the ground is pushing up on it to balance it out. And normal, remember, means perpendicular. So if I take that, I can look at it and say, hey, the normal plus this y component has to be equal to 157. Or another way to think of it is, if I take 157 minus the 16.3, that's going to give me the normal force, which ends up being 141 or 140.7 newtons. Okay, so that's in the y direction. Now I think those sort of cancel out. Now I'm getting ahead of myself a little bit here. When I look at draw a force diagram, okay, so I'm working on the force diagram. How much does your desk mass? So we answered that question. That mass is going to be 16.02, right? 16.02 kilograms. What are the components of your force? So we answered that. We said that the y component of the force is 16.3 newtons. And we said that the x component of the force is 60.85 newtons. How much is the normal force? Looks like we've answered that already also. So notice that as we go about filling out our force diagram here, we end up answering all the questions, kind of the same way in 2D kinematics. As we filled out that table, we ended up answering the questions that are being asked of us. So that normal force is 140.7 or 141. So now the last question then is, if friction is 56.3 newtons against you, how much will the desk accelerate? So to finish this out, then I'm going to have a force of friction acting on this. And remember, if it's acting against me, so I'm pulling to the right, then that means that the friction has to be pulling to the left. So this is the force of friction. It's going to be 56.3 newtons. So when I look at those, remember that we just said that the up and down forces, so these cancel out. If I'm going to do F equals ma now to find the acceleration, this is the net force, or the sum of all the forces. Well, the only two forces I have left, because the up and down canceled out, are left and right. So I can say that the x component minus the force of friction is going to equal mass times acceleration. And then I'll have the 60.85. I can substitute my numbers in. 56.3. The mass we found to be 16.02. And we can solve for A. So 60.85 minus 56.3 divided by 1602, and we end up with an acceleration of 0.284 meters per second squared. So now that would be the end of the dynamics part of it. There could be an F, and what would that F ask you for? Yep, it would take you back to kinematics. So it might say, hey, if your desk had an initial velocity of 0 and it now has this acceleration and you pull it for a certain amount of time, like maybe 2 seconds, then how fast is it going after that time, or how far did you drag it? So it would take it back to those kinematics ideas. So all of these dynamics problems, you're going to start with a force diagram and put all of your forces out. If your forces aren't in the X or Y direction, then you're going to break them into components, kind of like we broke up that 63 newtons. And then all of the up and down forces will cancel out. And the difference in the left and right forces, the side to side forces, will give you the acceleration based on Newton's second law.